Today I'm demonstrating the DesignWare IP Prototyping Kit for Ethernet QoS with a PCI Express host connection. This kit provides the essential hardware and software elements needed to reduce IP prototyping and integration effort so you can start implementing the IP in an SoC in minutes. The kit includes a Synopsys HAPS-DX FPGA-based prototyping system with pre-configured IP and SoC integration logic, a 4-channel gigabit Ethernet PHY card that includes 4 RJ45 connectors, simulation test bench and reference drivers. This kit also includes a multi-gigabit SerDes interface card which creates a 4-lane PCI Express bus interface between the HAPS-DX system and the PC. Here is the HAPS-DX system, 4-channel gigabit Ethernet PHY card and multi-gigabit SerDes card for the PCI Express connection. The kit includes an SD card with a DesignWare Ethernet QoS and associated SoC integration logic, which I will plug into the HAPS-DX system. The 4-channel gigabit Ethernet PHY card allows you to use a standard cable to connect the hardware prototype to a network. With a multi-gigabit SerDes interface, you can connect the IP prototyping kit to the PC. All IP development kits are compatible with most software development tools, so software engineers can start driver and firmware development in their preferred environment. To see the IP prototyping kit in action, I'll first power on the kit and PC. For this demo, I will use a PC running a 64-bit Fedora Linux distribution. Once I boot a Linux OS, I will ensure there is no configured driver or IP address assigned to the system. I will install the DesignWare Ethernet QoS IP driver into the Linux kernel. The driver correctly applied Ethernet settings and IP address has been successfully assigned. The driver is now installed, so I'll run some standard network commands. First, I will ping the system to confirm that it's connected to the network and is receiving feedback from the requested remote IP address. With the Ethernet QoS IP fully operational, I'm ready to open my browser, navigate the web, and check the network performance. I can validate the IP's functionality and system performance using the included MAC Management Counter or MMC module. This module maintains a set of registers for gathering statistics on the received and transmitted packets. We can view both the transmit and receive statistics separately for easier performance analysis. For example, the number of TX and RX packets increases based on the network activity. In addition to its basic functionality, the driver can be recompiled to change the API, turn on the packet generator module and perform additional debug. Once recompiled, with the new settings, the driver needs to be installed. With the packet generator module enabled, I will run the application pgtest included in the Ethernet QoS IP prototyping kit. With pgtest, I can tune the bandwidth in each of the 4 available channels. Initially, the bandwidth is equally divided among all 4 channels, so each channel gets 25%. For this demonstration, I will reallocate the bandwidth within the pgtest application. After reallocation, I'll recheck the final system performance. Synopsys provides the driver source code within the IP prototyping kit so that designers can modify, update, or even create their own driver to suit their needs. The IP prototyping kit allows you to quickly and easily explore many different scenarios. As you can see, this kit works fine out of the box. However, designers can modify the IP configuration for their own applications, using a set of tools for a fast iteration flow. This flow uses the Synopsys Core Consultant tool with a simple GUI interface to change the configuration, generate RTL, and verify the IP integration, using the simulation test bench environment provided with the kit, all in about 1 hour. Core Consultant allows designers to change or select the configuration through a simple GUI. This intuitive interface guides you through the available options for fast reconfiguration turnaround time. When you are finished, clicking Apply generates the RTL. The IP prototyping kit includes a Protocompiler DX intuitive GUI interface used for design synthesis or Tcl script to expedite the process and complete the placing route. Once the design is modified and reloaded in the SD card, you can check key internal signals and status registers. The IP Prototyping Kit comes pre-instrumented to capture relevant signals using Deep Trace Debug. This capability gives designers the ability to view several seconds of waveforms to speed up debug iterations. This is done by taking advantage of 8GB DRAM on the HAPS-TX FPGA-based system. The DRAM captures RTL waveforms that can be viewed on popular hardware debuggers, such as Synopsys Verdi or most other waveform viewer tools. After you've completed your software and hardware development, the IP Prototyping Kits can easily connect through an AXI tunnel to a HAPS-70 platform, creating a large SoC prototype. You have seen how the DesignWare IP Prototyping Kit for Ethernet QoS provides immediate productivity for both hardware engineers and software developers. Thank you for watching.